Hey everyone, today I'm going to briefly talk about GraphQL. GraphQL is a query language for developing APIs and it's getting good level of developer attention with many popular APIs going ahead with using it. For example, GitHub and Yelp are some popular adopters and obviously Facebook because GraphQL was developed by Facebook and released in 2015, so it's very new in this field. It can be seen as an alternative to REST, but it should not be used to replace all RESTful APIs. We will discuss more about when it makes sense to use GraphQL versus when to avoid it. With modern day web applications, more and more data objects are required to provide the user experience that we want. And GraphQL specifically solves the problem of needing several back and forth API calls to get all the data required on the front end. And all these back and forth API calls shows up as latency on the front end. Let's look at an example to see how GraphQL is different from other API specs. Taking an example of Facebook Newsfeed page, there are so many data objects required to render that page. Your web page or application would need to get a lot of data objects. For example, it would need information about relevant posts, information about likes, reaction for each of these posts, information about number of comments on these posts, information about some popular comments on these posts, information about author for each of these comments and also these posts, and get info about likes on each of these comments. And all of this information is required to be able to show some part of the page, and to provide that user experience. And it can easily go much further when you look at the possibility of comments having replies and these replies having their own associated info like reactions. So there are a lot of data objects that we need. And in RESTful world, this would be several calls to the backend. Some of these calls could be merged, but practically most of these calls would be independent and not all of them can be made in parallel. If we try to merge these multiple calls in RESTful world, we might make a change to the schema on the backend, but then the API would be very specific to this page layout. And as page layout changes, the API may need change to be optimal. Also, such an API will be less versatile and may not be easily reused for other pages, which might require similar data, but maybe in a slightly different shape. So let's see how GraphQL changes this. So in case of GraphQL, we can get all that information in just one call. So not saying that we should get all that information, all those data objects in just one call, but it's possible. And the decision to make decision about what data objects to get in one call can now be made by people who are working on the front end. And they can make that decision based on what provides the best user experience. So it is possible to get all information about less number of posts and then follow up with more information about posts that are not really shown on the page because user has to scroll to get all the posts. Uh, or other option is we can get all in basic information, very basic information about more number of posts, and then follow up with more information about likes and comments. And this decision has an effect on user experience, and the decision will now be made by the front end team who needs or who knows the best about the user experience because those are the people who are building that user experience. So GraphQL is based on idea of serving graph of data as we saw. So this graph of data is a set of objects that are associated with each other in some manner. A GraphQL API becomes more powerful as more related data objects are served through it. GraphQL stands out from other API technologies as it allows the client to get exactly what they want, nothing more and nothing less. For example, clients can get info about posts uh, or info about post plus author or any other permutation of objects that are related directly or indirectly. And also, Inside these objects, client can define specifically what fields are needed. Ability to get exactly what the client wants is possible through GraphQL queries. So let's have a quick look at GraphQL queries and other GraphQL operations. So GraphQL has three different type of operations, and they are to some extent analogous to verbs in REST, like get is read, put is write. You'll understand more as we go through them. The first operation in GraphQL is query. So query is a read operation in GraphQL. GraphQL is designed to get possibly large set of data objects which are interrelated to each other, and query helps us do just that. This is where GraphQL shines the most. Queries allow the client to express exactly what fields are needed, and then server responds accordingly with just the required fields in the response. Second operation in GraphQL is mutation. Mutation is a write operation. Mutation is the operation type used to make any type of change in the data on the backend. In my opinion, mutation is a required operation. It does what it is supposed to do, but it is mostly not a point of consideration when you're deciding for or against GraphQL. Queries is where the power of GraphQL comes from. Third operation in GraphQL is subscription. Subscriptions are long-lasting operations that can be used to implement a push model. Uh, Subscription can be used to share updates from the backend to the front end as they are available. Mostly, this is done through a WebSocket connection between server and client. Unlike other two operations, data share in this case would be triggered by the server instead of the client, but only after a client has subscribed for a specific subscription. The client will keep receiving updates to subscription till connection is closed by the client or disconnected due to network or server related issues. I would not use this for event-driven architectures as an alternative to GMS, AWS SQS, Kafka, etc. because GraphQL subscriptions are more suited for sharing updates with front end, like updates made to Facebook comments. This is because GraphQL subscriptions do not have a queue, and it's not essential that client may receive all the updates. It's not a durable connection like we would have, let's say, with AWS SQS. Just for context, this is what a GraphQL query looks like. So these are queries sent to server as request body to same GraphQL endpoint. And as you see in this example, client can use queries to ask for just the country name, as in the first example, queries are on the left and then we have the responses on the right. Or the client could ask for country as well as name of the continent, as seen in the second example. And the server will respond accordingly with the fields that are requested by the client. I will add the link to a quick GraphQL query demo in the description if you want to dive deeper. So let's look at when to use GraphQL. So as we saw, GraphQL really shines when data being shared through the API is a set of objects with relationships between them. As more relationships are needed to be served through GraphQL, it becomes increasingly useful. So that's a good use case to use GraphQL. Related to the first use case, GraphQL can also be used as an aggregator of data coming from several microservices behind the scenes if these data sets are related. This makes it easier for the client to find what is available using documentation for just one endpoint and also get all the data through one endpoint. This also helps with development as GraphQL can take care of aggregation for the most part, and developers do not need to write custom code for all aggregations. Apollo GraphQL implementation provides a powerful way to aggregate multiple GraphQL services through GraphQL Federation, and other implementations have similar options to allow this easily. Though your backend microservices do not need to be GraphQL based and could could be using any protocol or spec like REST, gRPC, uh, and all of them should work. So third use case would be as you as GraphQL provides a way for users to define specific fields to retrieve. GraphQL is also useful when multiple clients need similar data, but not all clients need all the data or need the complete hierarchy. GraphQL can serve all these clients optimally through different queries, but with the same backend code. And then clients can decide what are the different fields or different objects that they need. And we do not really need to change anything on the backend. With that, let's move on to when not to use GraphQL. I think GraphQL is not really built for microservice to microservice communication as it adds overhead and complexities because of the flexibilities that it provides. Network overhead of not sending extra data does not provide much benefit given microservices are mostly housed closer to each other. So microservices are not really able to benefit from what the GraphQL has to provide. Other technologies like gRPC or even REST have lower overhead than GraphQL and might be better suited in such scenarios. This is mostly true for communication between microservices for the same application group, but an external client service may still benefit from using GraphQL. GraphQL in some cases may be an overkill if the API is very simple and data objects are fairly independent of each other. GraphQL provides most value when data objects served have relationships and form a graph of data. REST might be a good choice in such case as it is popular and there are various frameworks that help with starting a simple RESTful service very quickly. Another reason to not use GraphQL would be that client is constrained or not willing to use GraphQL. Let's face it, REST is still the default choice for most of the web. Some clients may not be willing to use GraphQL when they have a learning curve involved, or they might have other constraints that do not allow them to use GraphQL. GraphQL is typed query language, and GraphQL clients provide a lot of useful checks and caching abilities that a simple HTTP client may not. So it's very helpful to use a proper GraphQL client for GraphQL APIs in most cases. And if we do not have a GraphQL client in the language that you want to use, then you will not really have the best experience. Before we end, I wanted to make a quick note on caching capabilities. As GraphQL can return much more complex objects easily and practically, it may not be useful to use the same strategy for caching as you would do in a RESTful API. This can be seen as a disadvantage as you need some work to configure caching. And there might be some learning curve involved to understand caching for GraphQL because it's more complicated than caching for a RESTful API.